Welcome to this lecture about MANOVA. Today, we will discuss about what is MANOVA and the disadvantages about MANOVA. When there is more than one independent variable, it is inappropriate to do a series of univariate tests. When we say univariate test, a statistical test that examines a single variable at a time. Multivariate analysis of variance, or MANOVA, is an extension of analysis of variance used with two or more dependent. Analysis of variance, or ANOVA, is used to compare the means of more than two groups. What is MANOVA? MANOVA is variation of ANOVA, which you already know. MANOVA is essentially ANOVA, but extended to analyze the differences and means for multiple dependent variables at the same time. MANOVA assesses the statistical significance of the effect of one or more IVs, or independent variables, on a set of two or more dependent variables. MANOVA assesses the statistical significance of how one or more independent variables influence a group of two or more dependent variables.
Why MANOVA? MANOVA has the ability to examine more than dependent at once or simultaneous effect of independent on multiple dependent. MANOVA is like a superpower of statistical tool that lets you study how things affect multiple outcomes at once. Imagine you want to see how a new teaching method influences both math and reading scores. MANOVA can analyze both scores together, giving you a clear picture of the overall impact. Okay. The major benefit of MANOVA over multiple ANOVAs equals to controlling type of error rate. Think of it like this: MANOVA is like a detective who looks at all the independent at once, while multiple ANOVAs are like detective who only look at one piece of evidence at a time. The more evidence you look at, the higher the chance of making those mistakes by analyzing everything together. How's it to do that? Overall, omnibus MANOVA is run to determine if significant, if should, then univariate ANOVAs are conducted for each dependent. Dependent must be correlated in MANOVA. MANOVA has included the correlation between independent. Therefore, the analyzing removes account for any redundancy and dependence. Example: case study on two different textbooks and students improve in math and physics. Dependent variables: here are improvement in math and physics. Our hypothesis, but the dependent are affected by differences in textbook. And in the last, MANOVA is used to test this hypothesis.
Disadvantage and advantage. MANOVA advantages. It tests the effects of several independent variables and several outcomes or dependent variables within a single analysis. It means The advantage of multivariate analysis of variance or MANOVA over univariate ANOVA. Key benefits or MANOVA highlighted include MANOVA's ability to analyze multiple dependent variables simultaneously, increasing statistical power and reducing type their error rate compared to performing multiple ANOVAs. MANOVA is consideration of intercorrelations between dependent variables, provides a more comprehensive and realistic analysis of the data. The power of convergence point emphasizes that a single dependent variables often inadequately captures complex phenomena, while MANOVA's multivariable approach offers more complete understanding. Finally, the reduced risk of type error inflation due to multiple comparisons is a significant advantage for researchers. Advantage of MANOVA over ANOVA. MANOVA produced significant mean effect on the disadvantage, but ANOVA do not, because variables are more significant together than considered separately. Means it highlights that MANOVA can find significant effects on independent variables that ANOVA misses because it considers the combined effect of multiple, accounting for intercorrelation between them. This holistic approach also helps control the inflation of type or error or false positive that can occur when performing multiple ANOVAs. MANOVA disadvantage means first, the discriminant. Function used in MANOVA, while effective for separating groups, are not always easy to interpret conceptually. A significant effect might be driven a complex combination of dependent variables, making it challenging to understand the underlying relationships. Second, MANOVA, like discriminant, analyzes release on several assumptions that can be difficult to assess and meet in practice, potentially affecting the validity of the results.
A word about power. The power of a MANOVA actually depends on the nature of the dependent correlation. Power increases in relation between dependent variable with large consistent effect sizes that are in the same direction, move from near 1 toward -1. Power increases as relation become more positive or more negative between dependent variables that have very different effect sizes, one large and one negligible. Power increases as correlation between dependent variable with negligible effect sizes shift from positive to negative, assuming that there are dependent variable with large effect sizes still in the design. Means the power of MANOVA is intricately linked to the relation between dependent variable. When dependent variables have large consistent effects, negative correlation both power more than positive ones. Conversely, if dependent variables have differing effect size, positive or negative, increase power.
Finally, for dependence variable with negligible effect, a shift from positive to negative correlation enhance power, provided other dependent variables with substantial effect are present. Therefore, understanding dependent correlations is crucial for interpreting MANOVA result and assessing its power. Roles, just like in ANOVA, dependence variable must be continuous. And dependence variable are categorical. Covariates might be included and must be continuous. All assumptions of ANOVA hold with a few minor exceptions. Means MANOVA, like ANOVA, requires continuous dependent variable and categorical and dependent variables covariates if used must also be continuous. While MANOVA largely share MANOVA's assumption, there are some minor differences. Assumption of MANOVA: multivariate normality, homogeneity of covariance matrix, independence of observations, linearity. Means MANOVA relies on several key assumptions. Data should follow a multivariate normal distribution. Covariance matrix across groups had to be roughly equal. Homogeneity of covariance matrix. Observations must be independent. Finally, a linear relationship should exist between the dependent variable and independent variable. Violation of this assumption can compromise the validity of MANOVA result.